Now we have come to the end of motion on pulleys. I want to believe that you have understood every bit and everything that we have done in motion on smooth pulleys. Now the rest of the topics in first week is work, energy and power, which we are doing today. Watch the video with keen interest. Don't rush. Pause if possible, then you move on. Now, what is work? Work is said to be done when a force moves an object or a body through a particular direction. I say that again. Force is said to be done when a force moves an object through a particular distance, rather not direction, through a particular distance. So we can therefore say that work is equals to force times distance. Note that force equals force times distance. So work is said to be done when a force or an effort moves an object through a particular distance. So we can therefore try to build up a formula. So we have said that work equals force times distance. Please note these equations very well. This is used when we are given force and we are given distance. Now we also recall in second law of motion that F is what? ma. So you can also have this formula, equation 2. So you can be asked to calculate work when you have been given mass, acceleration and distance. We can also be asked to calculate work if we are given, because force and weight, they are related. Sometimes when you are giving acceleration due to gravity, we can also use this. That is equation 3. Now sometimes work can be done on an inclined plane or on a plane this way. Now let's assume that we have a box here, and this box is to be pushed horizontally. So we have horizontal direction, horizontal component or horizontal direction, then we have vertical direction as well. That means it depends on the angle at which you are pulling it. Let's assume that we are pulling it at this angle, so we can resolve the plane this way. We have horizontal component, we have vertical component. So this vertical component, let's call it y, and let's call horizontal component x, and this is the force that is pulling the object this way. Now how can we resolve for the x? How can we calculate x? This is angle 90. Using your SOHCAHTOA to calculate x, that becomes adjacent over hypotenuse, and that is what, everybody? Cos. So cos theta equals adjacent over hypotenuse f. So that becomes what? Horizontal component will now be equals to f cos theta. Does that make sense? Yeah. Now the next one is to resolve for vertical. This is opposite here over hypotenuse, and that is what? Sine theta. So sine theta equals opposite over hypotenuse. If you cross multiply, f becomes what? Sorry, y becomes f sine theta. You can pause the video and watch again. So vertical components. So our equation 4 now will now be what? Work done on the horizontal will now be force times distance, and we have calculated the force on the horizontal, which is F cos theta. So we have F cos theta times the distance moving, and that is s. We can equally calculate the work done along the vertical direction, and that becomes what? Also F sine, because we have already calculated the force for that, and that becomes F sine theta times distance. So we are going to stop there for the formulas for work done. See you in the next video for energy.